All right, so let's get started. In this webinar, we have a lot of fun things going on. It's a little different from our usual monthly webinars. First of all, we have one of our distinguished guests, Tim Pearson from Pittsburg University. Pittsburg is one of Hedvig's customer, and he'll be discussing his architecture, his infrastructure today, how he's leveraging Hedvig for solving his problems. And we are also giving away a lot of prizes today. So we have what in fact we'll do is we'll ask you questions during the webinar, and you can answer those questions using the chat window, and we'll reach out to the winners after the webinar. So the prizes that we are giving away is $500 worth of gift cards, and we also have a lucky winner or a grand prize in which we are giving away Apple Watch, and that will go to the person who is attending this entire webinar, who stays with us during the webinar, and we'll reach out to you after the webinar as well for the grand prize too. So let me start with the introductions first. My name is Gaurav. I am product manager at Hedvig. I have with me Srividya, and she is one of our senior engineers at Hedvig. And I also have, as mentioned, Tim Pearson, who is Assistant Director of IT Infrastructure and Security at Pittsburg University. So he will discuss, as I mentioned, his infrastructure, what are the problems that Hedvig is solving for him, and he'll give you kind of a quick live introduction or kind of a demo of what his internals look like. And Srividya, who has worked very closely with Tim, will kind of help you understanding a few more specifics of the deployment and installation. What I'll do is I'll give a quick Hedvig introduction to begin with, and then I'll hand over to Tim for the rest of the webinar. And at the end, we'll of course have Q&A. And you feel free to ask any questions during the webinar. Just type it in the chat window, and I'll try to answer as many as I can, either during the webinar or at the end of the webinar. All right. So let's get started with the introduction itself. What is Hedvig and what are the problems that we are solving? So at a very high level, Hedvig is making enterprise storage cloud easy. Now, what does that even mean? So Hedvig is a software-defined storage solution which can be deployed on any infrastructure, which means it can be deployed on any standard commodity x86 or ARM servers. As you can see, any of these hardware vendors you can bring in, like HP, Quanta, Dell, Supermicro, and Hedvig can be installed on them as a software layer to consolidate all the capacity drives attached to any of these servers. Hedvig can also be installed on any of these public cloud locations, be it AWS, Azure, or Google Cloud, and provide a stretch cluster semantics across your on-prem locations, which could be across multiple racks, multiple data centers, different sites, or even any of these public cloud locations, and give you a single pane of glass view to consolidate all the storage across these disparate locations. Now, what are the kind of workloads that we support? So we start with virtualization. So we work with any of these standard hypervisors like VMware, Hyper-V, or KVM. Hedvig also provides a vCenter plugin, and Hedvig provides VAI capability as well for VMware. And also Hedvig provides a lot of integrations with OpenStack to deploy your own private cloud. So Hedvig integrates with OpenStack Cinder as well as OpenStack Surf. Then Hedvig provides integrations with containers as well. So these standard container orchestrators like Docker, Kubernetes, Mesosphere, and even Red Hat OpenShift. Hedvig is literally one of the first, if not the first, software-defined storage vendor to provide a certified Docker plugin, which is available from Docker Store as well. And in the backup space, we provide integrations with your well-known backup applications like Veritas NetBackup, Veeam, and Commvault. And this is how Hedvig allows their customers to consolidate these different workloads, so bringing these different kind of workloads, be it virtualization, containers, or backup, using the exact same Hedvig cluster, using exact same Hedvig distributed storage platform, and makes their life easy and to avoid having multiple storage silos in your data center and having to deal with multiple vendors. You can get rid of all of that with the simplicity of Hedvig distributed cluster. And in terms of the storage protocols itself, Hedvig provides integrations with block protocol, file, as well as object storage. So for example, iSCSI, NFS, AWS S3, or OpenStack Swift, Hedvig makes it easy to work with any of these standard protocols. So you can migrate your traditional applications from your any of these existing storage vendors to Hedvig seamlessly. So this is a very quick introduction of Hedvig. And what I'll do now is hand over to Tim, and he'll go over his use case and give you more details and specifics on how he is using Hedvig to solve his problems at Pitt State. Tim, please go ahead.
Okay, thanks, Gaurav. Hi, folks. My name again is Tim Pearson. I am my fancy title is the Assistant Director for Infrastructure and Security at Pitt State. And practically what that means is that I lead the team that looks after the data center, the campus network, and the voice communications, the phone system, part of our infrastructure, and the IT security officer is also part of my team. I've been involved in IT for about 30 years. I began back when 256 kilobytes was considered a lot of storage, and have been involved in IT ever since. I've been with Pitt State for about 10 years now. For just a little bit of background about the university, Pitt State is located in Pittsburg, Kansas, which is in the extreme southeast corner of the state. It's right where Kansas, Oklahoma, Arkansas, and Missouri come together. Pitt State has around 7,500 undergraduate and graduate students enrolled. And one of our unique attributes about this particular university in Kansas is we are the home of the Kansas Technology Center, which is kind of unique in that it partners with a lot of industry. We have one of the few schools of construction in the United States that teach students how to become site foremen and those kinds of things at large construction projects. One of the things that kind of first got us interested in moving away from what I would call the traditional sand storage and backup tapes in the safe deposit box at the bank kind of approach was an event that happened right across the state line in Joplin, Missouri. And I actually live in a small bedroom community of Joplin and commute about 25 or 30 minutes over the state line into Kansas to come to work every day. But back in 2001, I think it was, an F5 tornado hit the city of Joplin. It was about, the winds were measured in excess of 200 miles an hour, $2.8 billion in damage. It took 160 lives as it tore about a mile swath through the city. We had folks that I've grown up with in IT that ran data centers in Joplin that had even some of the hardened data centers damaged by this tornado, and data centers were offline for a significant period of time. So we, in being only a few miles away from where that tornado hit, realized that that could very easily have been us at Pitt State as opposed to being in Joplin. So using the technology that was available to us then, we began to do some things to try to distribute our infrastructure using more traditional approaches that were available in that era. We purchased a second SAN. We began to do timed replication of our data from one SAN to the other. One was located in our primary data center, and the other one was located about, well, not quite a mile away in the basement of our library. And then using the Kansas Research and Education Network, which is owned by the Kansas universities, all 7 of us, we were able to secure some high-speed network connectivity to Wichita State, which is one of our sister institutions. And we placed some storage at Wichita State and began to store our backups there as opposed to tapes at the bank, basically. So that was kind of phase one of our attempt to distribute our infrastructure a little bit. And that infrastructure began to age over the years as well. Those SANs were all spinning disks, and they began to age, and we saw the failure rate of those disks increase. And that was a big issue for us. One of our neighbor universities actually ended up having to cancel school for a couple of days because their traditional SAN had 2 back-to-back hard drive failures that the SAN couldn't tolerate. And they had to get SAN vendor engineers involved to try to get that data recovered. So that was kind of, we had made our decision that we were going to do something before that happened, but it was in some respects served to help reinforce to the university's leadership that this was a significant problem that we needed to address. The primary workload that we use Hedvig for is VMware-based virtualization. I'll show you here in a few minutes our vCenter environment. We also use a Unix host that accesses this storage via iSCSI. This is a legacy system that our student information system still runs on. We have just recently migrated our financials and most of our other core applications to a newer technology on a newer platform. But we still have this Unix host, and it still needs to have good resilient storage. And that was one of the design constraints that we looked at when we were looking for a storage vendor back at the time we ended up choosing Hedvig. And of course, we wanted to also be able to maintain the idea of distributed data across multiple data centers. And that was something that we found, or we thought Hedvig did more elegantly than many of its peers. This is a graphic that kind of shows you how our existing infrastructure is laid out. We have 3 Hedvig storage nodes, one in Kels, which is the building that I'm in. Axe is the Leonard Axe Library, which is across campus. And Wichita State, WSU, is our remote storage across the state. We actually have hardware that belongs to Pitt State in the Wichita State data center connected to the other 2 Hedvig nodes. Then in the Kels data center, we have some ESX hosts. Those are the larger squares, each one supporting a population of virtual machines. Then we have some additional ESX hosts in the Axe data center. And we use, for those of you familiar with VMware, we use VMware's high availability feature to be able to automatically restart VMs on available ESX hosts in the event of a failure. So, for example, if we were to lose a host in the Kels data center, or even the entire Kels data center, VMware HA could restart those VMs on spare capacity that we have in the Axe data center. And we actually architected the ESX hosts so that there would be enough headroom, there would be enough spare capacity in the physical servers that we could run. It would be tight, but we could run our entire workload either in either one of our on-site data centers. This gives you an idea as to how the data centers are laid out. 24 terabytes of capacity in each one. We're using a replication factor of 3, which means that every time a piece of data gets written, a data block is written, it is written to all 3 storage locations, both the 2 here on campus plus Wichita State. And we also have 2 VMware clusters connected to Hedvig storage. We actually have a small amount of ESX hardware at Wichita State, and we can run virtual machines from Wichita State if needed. So that gives us the ability, in case of a real disaster where the university might get completely isolated from the internet, we can spin up our web server and some other very critical applications using an ESX host that we have at Wichita State and connect to the same Hedvig storage cluster that you see here. Okay, now I'm going to drop the slide presentation and give you a live view of our production cluster. This guy has 6 ESX hosts, and these are HPE DL360s. They support about 130 virtual machines across those 6, and you can see the virtual machines listed here for those of you familiar with VMware. I was going to kind of walk you through some of the connectivity, how the pipes are actually connected together to get Hedvig data supplied as data stores to VMware. If we take a look a little further down the list here, you will see a list of virtual machines that all begin with Hedvig. And this first one is just a deployment server. It's used when there are software updates or other things that need to be applied to our entire infrastructure. There's some scripting automation in the deployment server that makes that a much faster and more straightforward endeavor than if you had to log into each individual virtual machine and storage node to effect a change. And then you'll see these Hedvig SP virtual machines listed here. You see O1A and O1B. That corresponds to the first ESX host here. So ESX host number 1 has running on it 2 Hedvig storage proxies. What these are simple, straightforward Linux CentOS 7 actually virtual machines that have a virtual network card on a host-only network to connect on the ESX side. They present what ESX thinks are NFS data stores, basically. And then on the back side of each one of the storage clusters is a connection to the storage network where the Hedvig storage nodes live. Those are the servers that actually have the large population of SSDs and spinning disks that store the data. So these are basically just gateways that talk Hedvig protocol on the back side and one of several standard protocols on the front side. The one we're using is NFS for connectivity to our ESX hosts. And we're also using iSCSI for connectivity to our legacy Unix system. And that's handled by these last 2 down here at the bottom. Rather than having an IP address on a host-only network for connectivity to ESX appear on these proxies, these 2 are for external clients to be able to access Hedvig. And these present iSCSI storage to our Unix host. And they could present NFS or iSCSI or other protocol driven storage to other external devices. And we could have more than just these two proxies hosting external devices. And they don't have to be virtual machines. They could be physical machines. The trick is that they need to have some fast disk, solid state disk on them, because in addition to providing that protocol translation, they also do caching that accelerates I/O. The other thing I'd mention about the storage proxies here is you'll see there are 2 for each one of our 6 ESX hosts, and there are 2, excuse me, 2 externals. These are in an active standby arrangement with automatic failover so that we're able to do software upgrades or maintenance on any of the storage proxies. So long as we leave at least one of the 2 running, the ESX host will continue to see all of its data stores. And the same thing with the external proxy down here. And that's something that's a little bit different than some of the other vendors we looked at. They used a similar storage proxy virtual machine kind of approach, but they didn't give the failover redundancy. You didn't get 2 of them. So if the storage proxy went down, then that ESX host lost connectivity to all of its NFS data stores. If we go over and take a quick peek at the data store view, you will see these guys up here at the top are for the storage proxies. These 6 SSDs, there's one in each one of our ESX hosts that provide a cache volume that's shared between the two storage proxies. And then these 6 drives are small spinning disks that the storage proxy operating system lives on. This is where the boot volume and the root volume of the Linux virtual machines run. Then you'll see some additional storage data stores here that begin with ESX or ESXi. Those are connections, iSCSI connections to our legacy SAN that we were running on exclusively before we installed Hedvig. And then the data stores down here that begin with H or HF are NFS presented to ESX as NFS data stores, and they are all provided through the storage proxies back to Hedvig storage nodes. And the naming convention was just something we chose. The HFs down here, those are backed by flash storage, by solid state storage on the storage servers, and the remainder here are backed by spinning disk. The suffix here, CO, means the volume is compressed. DD means the volume is globally deduplicated and compressed. And we took a look at the characteristics of the virtual machines that ran in our cluster to determine what made sense to put on deduplicated volumes and what made sense to put on just compressed volumes. Not every workload is necessarily dedupe friendly, and if you're not going to gain a lot in savings by putting a workload like that on the deduplicated storage, you might as well gain a little bit of performance and use a compress only alternative. If there's going to be large amounts of ephemeral data, lots of change and turnover and churn, deduplication doesn't necessarily buy you much in those environments. So why spend the overhead to do things that way? If we take a look at one of the deduplicated volumes here, you can see that all 6 of our hosts have connectivity through NFS to the volume. You can see the virtual machines that are running on that volume. And then if we jump over to the Hedvig GUI, you can take a look at those same volumes in the Hedvig management interface. And if we take a look at the tier 4 deduplication volume number 1 there, and let's pull up its details, and you'll see that deduplication and compression are enabled, and that while we have written 2.2 terabytes of raw, uncompressed, undeduplicated data to this data store, we're only consuming, after compression and deduplication, 335.4 gig of storage on the Hedvig storage cluster. So we're gaining quite a bit of advantage storage-wise by using deduplication and compression on the population of virtual machines that we're using deduplication on. And some good examples of that might be, I've got an application server that's got a Windows directory and a document root for some kind of Windows web service running on it. The drive is relatively static, things don't change much. That's a good candidate to live on a dedupe volume. On the other hand, if I've got a volume or a virtual machine that is constantly importing and exporting huge volumes of unique data, that's not something that's going to benefit much from deduplication. So we don't store that. We could, but why pay the performance penalty for that? So if you take a look overall, you'll see that we've got about 24% of our cluster in use, and deduplication, and you'll notice that we don't have that much deduplication turned on right now, is still saving us 67%, which is pretty fairly significant. Our total cluster size here is 193 terabytes. Of that, 174 is usable, and we've actually consumed about 47. So with a replication factor of 3, then if you're dealing with data that's not compressed and not deduplicated, then every 1 gigabyte of raw data would consume 3 gigabytes on the Hedvig storage cluster, because we want to replicate that to all 3 data centers. So being able to benefit from the compression and deduplication is really advantageous in that event. The other thing that I would mention from a VMware standpoint, all of the things that you're kind of used to doing in VMware with respect to storage vMotions or load balancing vMotions of virtual machines, all of those things still work, just like they would if you were connected to traditional storage. And you also have the ability to do VMware level snapshots, but the new thing with the Hedvig system is that we can also do snapshots at the Hedvig level, which if you've got a traditional SAN, being able to take SAN level snapshots is probably something that's not unfamiliar to you. Today, we still do traditional backups, but I believe there will come a time when we will rely on scheduled snapshots in Hedvig to replace the traditional backups that we're doing today. But we wanted to kind of develop a bit of a comfort factor with the new storage system before we abandoned doing traditional backups. But of course, the advantage to that is restoring from a SAN level or a Hedvig level snapshot is a virtually instantaneous process. Whereas with a 2 or 3 terabyte email repository, restoring that from a traditional backup will take hours and hours and hours to accomplish. So it gives us recovery time objective improvements that are on an order of magnitude or better when we're talking about needing to recover data from a large virtual machine. So that's kind of a quick overview of our particular environment and the way we're consuming Hedvig storage today. And I guess next is to see if you guys have any questions.
Great. Thanks, Tim. I appreciate all the detailed information on your infrastructure and how you're using Hedvig. It was really helpful, I think. And before I hand over to Srividya to have a little bit of informal Q&A with Tim, and also answer any of the questions that our audience might have on the webinar, first of all, just let me start by saying, if you have any questions, please start typing it out in the questions window on the GoToWebinar. And as mentioned earlier, we have a lot of prizes on this webinar. So I'll ask a couple of questions, and feel free to answer them in your chat window, and we'll reach out to you after the webinar to give away almost $500 worth of gift cards. And of course, there's a grand prize of Apple Watch as well. So I'll ask the questions and give a few seconds for you to give your answers in the chat window, and we'll reach out to you later. So the first one is, name any 2 public cloud vendors where Hedvig's software-defined storage solution can be installed. So just name any 2 public cloud vendors. So that's the first question. Now the second one is, name any 2 container orchestrators for which Hedvig provides volume integration. Any 2 container orchestrators for which Hedvig provides volume integration. So just type out the answers in the chat window, and we'll reach out to you later. And we have a few more questions that Srividya will ask you after this Q&A, and based on the webinar today. So yeah, I'll hand over to Srividya now.
Thanks, Gaurav, and thanks, Tim, for that detailed explanation. So now, Tim, I do have some questions for you specifically regarding Hedvig, and it'll be nice if you can answer them. So to start with, can you elaborate on how a single Hedvig fabric helps with operational efficiency, and in particular, like how it helped at PSU would be a great answer for that.
Sure. To start with video, we feel a lot safer than we did before, knowing that all of our critical data, including the most recent changes, are being replicated in real time all the way across the state to Wichita State makes us feel good about the fact that we're not going to have some catastrophic loss of data. That's one of the I sleep better at night, I guess, since we put the Hedvig system in. The other thing is we were looking for a storage solution that wasn't going to require a forklift upgrade in 3 or 4 or 5 or 6 years if technology changed. We had kind of been through that with our traditional SAN, and we wanted to be able to move towards a platform and an architecture that would provide us with storage solutions that we needed today, the NFS and iSCSI kinds of things. But my development counterpart here at Pitt State is already looking at solutions like Docker and being able to programmatically provision and access Hedvig storage using Docker containers is something that I think we'll be taking advantage of at some point in the not too distant future. The other thing that I like about this particular architecture is the fact that the touch point to implement new features is kind of at the proxy level. What we present to the outside world requires you guys, and by that I mean the Hedvig development team, to make additional features available to the storage proxies. What happens on the backside at the Hedvig storage node layer, those particular applications and protocols don't need to know or care. So that approach makes us feel confident that as new technology emerges, as I think Gaurav mentioned, that you're one of the first storage vendors who's certified, I guess, with Docker. So that's good news for us. I didn't know that until today. But I think we'll be ready to take advantage of evolving technology in a much more timely fashion than we would have been with many, if not all, of the other vendors we looked at.
Thanks, Tim, for that answer, and that leads me to the next question. So, what made you choose Hedvig as compared to the other vendors?
Sure, we took a look at several, and I actually discovered Hedvig with a Google search, and went to your website, and you had some good technical white papers that explained your storage architecture and how it was designed. And after about 10 or 15 minutes of reading, it became obvious to me that what you were doing was unique and that you could be a real player, a real contender for the university's business, because your strategic direction in the way you were developing this product very well aligned with what it was we wanted to be able to do today and in the future as things evolve. So that had a large impact on our decision. The other thing that influenced our decision significantly were the customer calls that we had with some of your then existing customers. And one of the things that each one of them went out of their way to stress was how good the support was from the Hedvig team, that it was unusual in the level of support and the timely responses and the engagement that they had seen with you over the years. And that was something that we felt was going to be of critical importance, especially if we're thinking about adopting new technologies. Sometimes support can be very important in those situations. So your reputation and your technical design philosophy had a lot to do with our decision.
That's awesome. So now is my last question, really. So why would you recommend Hedvig to others?
If you're in any situation similar to ours, I think this is going to be the best solution for you. If you're worried about data integrity, you're worried about data loss, you've got a situation where perhaps you might want to integrate with a cloud provider. I know you have some customers that are doing that have kind of taken what we are doing and extended it so that they have their private cloud provider Hedvig, but they also replicate data to the public cloud, and you can seamlessly provide that solution. It's just the technology just seems to have some real flexibility and agility. So that's one thing. And the second is, I've already mentioned a little bit about your support. I joke to people, for those of you who are listening, that Vidya probably knows more about the design and implementation at Pittsburg State than we do in some cases. And it's because she has been so helpful in being able to investigate our particular situation, make recommendations as to the best way to deploy things to get the best bang for the buck out of the product. We've found that the glowing reports that we heard from Hedvig customers about support were not unfounded, because we've experienced the same thing.
Thanks, Tim. Thanks for those good words.
Sure.
And I think we are done with the Q&A part right now, so we can move on to any questions from the attendees, if any.
Oh,
yeah, sorry, go ahead, Tim.
I was just going to say, you guys have our case study PDF up as a handout. If you want to learn a little bit more about what we've done, you can, anyone attending can certainly download that and take a look at it.
Great. Yeah, thanks for the information, Tim. And the one of the questions that we had from the audience was for you, Tim. What's the biggest issue from your point of view when dealing with multiple data centers?
Probably the biggest concern, and it's not that much of a concern for us because our remote data center is at a sister institution. So you get some of the collegiality that goes on between Kansas universities, and we are always able, if we need a reset button pressed or a drive replaced or those kinds of things done at Wichita, they've just been great to work with. But if that was not the case, if we had rented some space in a commercial data center at in some location and had hands-on maintenance that needed to be done, that could become an issue for us. As far as the situation as we are today, the way things are laid out with the management interface that's available to us both on the storage side with Hedwig and on the compute layer with VMware, it all manages pretty seamlessly.
Great. Yeah, thanks, Tim. So yeah, I think we are almost running out of time. So what I'll do is I'll let you ask a couple of more questions for giving away our prizes. So yeah, go ahead.
Hey, yeah, here are those questions. Question 1. Where is Pitt State University located? I repeat, where is Pitt State University located?
We are.
And Tim, you can't answer that.
Yeah, I know.
Oh, I'm sorry. Okay.
And the second question is, what kind of hypervisor does Pitt State use? I repeat again, what kind of hypervisor does Pitt State use?
Yeah, so please, as earlier, just answer those questions using GoToWebinar, and we'll reach out to the winners and give away the prizes after the webinar is over. I think that's pretty much it. That concludes our webinar for today, and thanks everyone for joining. Thanks, Tim, for shedding light on Hedwig in their own infrastructure, and that was, I believe, it was useful for our attendees. And yeah, thanks everyone. Thanks all the presenters, and thanks, Tim.
Thank you, guys.
All right. Bye-bye.
Bye-bye.